A new Earth-like planet has been found around a sun-like star, and this is, in astronomical terms, rather close, only 20 light years away. Now, this is exciting. I did report on a similar system that was 3,000 light years away a couple of years ago, and that was KOI 456-04. But this one is much closer at 20 light years away, and this planet is HD 20794D, and it orbits around the star HD 20794, which is also known as 82G Eridani. Funny names. It's in the constellation of Eridanus, which you can see in the southern hemisphere. You can't see that from up here in the northern hemisphere. However, some of my friends are in Australia. Maybe you've seen this constellation. It is the name invokes the river. That's what it means. But now, this is highly intriguing because this star, HD 20794, has multiple rocky planets around it. And the planet in question here, the D planet, is actually mostly it's within the habitable zone around that star. There is another planet, though, that actually is on the very inside edge of that habitable zone, and that would be HD 20794C. Anyway, so we'll go over that in a little bit. We'll talk more about B and C, because there's some interest, C especially. Now, the challenging thing about HD 20794D is that it's actually, these are like some big address, right? We got to come up with a better name. It's actually in a highly elliptical orbit. Like, let's say, if this is the star, if this is HD 20794, and this is HD 20794D, the orbit is not circular, it's more elliptical, which could be really challenging for any potential weather systems you have on that planet should it have light. Don't mean it's insurmountable. There are factors that may cover for that. But this planet is 6 times the mass of planet Earth. 6 times the mass of planet Earth. Now, if it has the same density as Earth, which is very probable because it is a rocky planet, probably iron core, like typical, with the crustal material on top. If it is 6 times the mass and it's roughly the same density, that would suggest that several things about its size and gravity on the planet and things like that. For example, if you're got 1 pound on Earth, 1 pound on Earth would be 1.81 pounds on this planet. So if you weighed 100 pounds on Earth, you'd weigh 180 excuse me, that's 181.6 pounds. So if average man at 199.8 pounds, it'd be 362.868 pounds, and the average woman at 175 point, I believe, would come out at 310 pounds, 310.172. That means if you were on the surface of this planet, if you could walk on the surface, we don't know if it's like an acidic atmosphere, an atmosphere that's extremely thick, like Venus, which might be too hot, it might crush you, or maybe no atmosphere at all. But if you could walk around on the surface of this planet, it's doable. I mean, we have people in the 300-pound weight range. I once had a weight knocking on 300 pounds some years ago. So it's doable. You just are not going to be moving around as fast, and it's going to be more of a struggle. But, if there are complex creatures on that planet, they got to be pretty muscular. But the cool thing about it, the really interesting thing about that is the size of the biosphere around that planet would be 3.3 times the size of the biosphere around Earth. That means it's like 3.3 Earths. That means if it can't support life, there's more opportunity for more diversity. I'm not saying it's there. I'm saying just more opportunity for more diversity should it support life. Now, what would it take for this planet to support life? Well, you need a magnetosphere. We just talked about that in a recent video. And Earth, as I said in that video, may have been gifted by the fact we had another large planet hit us, and we've got more probably iron inside our core of our planet. per our size that might be typical for a planet the size of Earth. Look at Venus, almost no magnetosphere. Mars had a magnetosphere, it's gone. The atmosphere got stripped off Mars. We discussed this in the past, but the presence of a magnetosphere may be a key thing. I just did a video on that that suggests that there could be life. Now, being a larger planet means it may have a larger iron core, which means it may indeed 6 times the density of 6 times the mass of Earth. Means it's got a good chance for having a strong magnetic field. Doesn't mean it does, but a really good chance. Another thing that we've learned of late is a lot of scientists are saying that we wouldn't have life on Earth, at least complex life, if it weren't for plate tectonics. I mean, the plates on Earth move around, and apparently that creates a lot of complexities and things. Well, hey, it gives us land, right? And it's not locked land. You know, if the whole water, if the world was covered by crust and things weren't moving around, water would have washed away all the continents and everything would be below sea level. So it would be hard for any complex civilization under sea level to smelt iron and melt ores and make copper wires, radio sets, and spacecraft. So that would be hard to see that coming about. So you wouldn't expect, you might have whales, you might have dolphins, you might have really smart marine animals, but they're probably not going to be starfaring. So you're probably not going to hear from them. You're not going to hear the radio transits. Now, you might have a planet like that. It could be a water world, and it might be an interesting world in that. But on the other hand, but then it's been even suggested even in the oceans you wouldn't have complex life. So there's a lot of factors that go in. Maybe we should visit that topic one day. But this planet, if it may have been impacted by a big rocky planet at some point, and it may indeed, we don't know, have plate tectonics. Now, we're the only example of plate tectonics in our solar system, so we got to kind of guess that maybe it's not as common in the rest of the universe as we would hope. Yet we've also got this large moon, probably another remnant of the fact we took a big whack at the inception of Earth, a big whack, and a lot of our crustal material got knocked off. The moon has far less density than the Earth. The density is roughly comparable to the crustal material. We're missing about 2/3 of it on Earth, thankfully, and it's covered with the oceans. So anyway, our continents get to move around and keep forming, and the pressures keep pushing land above the water line, thankfully. All right, all that said, so a lot of things go into whether or not you can have civilization. Another challenge might be if it were an eyeball planet. An eyeball planet is a planet that gets tidally locked to the star, so the only one side ever faces that star. It's like the moon and Earth. The moon has been tidally locked to Earth. You only see the same face every time you look at the moon. And we got a full moon tonight. Go out and look at it. You'll always see that face. There's a far side of the moon. It's not a dark side, a far side. Right now, since we're having a full moon, I assume right now that side is dark. But the lunar day is 14 Earth days. So actually, the sun does, moon actually does revolve, but it takes it 14 days for it to spin around, which is commensurate to its 28-day orbit around the Earth in such a way. Well, it takes it 28 days to spin around, but it means half of it's daylight, half of it's dark. Excuse me. So you get 14 that day on the moon and a 14-day night on the moon. All right, all that said. Now, in our solar system, planets close to the sun, some of them are not quite tidally locked, but the sun's definitely highly affected their orbit. You take the planet Mercury, it's in a 3-to-2 resonance orbit. For every 3 times it spins around Venus day, it goes around the moon twice, around the sun twice. So every 3 rotations of Mercury, it goes around the sun twice. Now that's interesting. Mercury's a small planet, easier to get tidal locked, and we got a big star. Now, in this case, for HD 20794D, that planet is a little bit closer to its star than Mercury is, believe it or not. And it's got 3 planets inside its orbit, A, B, and C. And I'm not been really talking about A. So the situation is that this planet is 0.35 astronomical units from the star HD 20794. Now, having said that, the Mercury is 0.39 astronomical units from our sun. It's not been totally tidally locked. Now, a bigger planet around a smaller star might be harder to tidally lock, but this system is older than Earth and our sun. Earth and the sun's believed to be about 4.5 billion years old. This system is 6 to 9 billion years old. So in a biosphere of 3.3 times the biosphere of Earth, if this had the same opportunities to form life and complex life as Earth has had, it may have had a lot longer and a lot more opportunities for some civilization to arise. 20 light years away. But there's a little problem. If we're restricted to chemical rockets for space travel, I do cover other topics, there's other possibilities. But if you breakthrough physics are not available, if you're restricted to chemical rockets, you got a problem. Because escape velocity from Earth, the velocity which a raw projectile's got to travel to fall around the horizon, what we call free fall or orbit, to continuously go around that planet in low Earth orbit here, is 17,500 miles an hour. Now, on the planet HD 20794D, since it's got 6 times the density. Now, see, the other things, it's not just the density, it's got to do with the radius of the planet, a lot of other things, how and that governs how gravity affects it going out. Like you don't weigh 6 times more on the surface planet. The moon has 1/6 of Earth gravity. You don't weigh we'll go on that a little bit. But the escape velocity, the moon is actually the density and its mass is not 1/6, it's the gravity is 1/6. The escape velocity from this planet is 45,465 miles an hour. 6 times more than the escape velocity from Earth. That's the kind of velocity from our planet you need to travel out to Mars and beyond. 45,000 miles an hour, you're in not just going to the moon, that's 25,000 miles an hour. You're on your way to Mars in our solar system from Earth. However, you gotta figure this: for every pound it takes to get something into space with a chemical rocket, even on Earth, most of that rocket's fuel goes to lift and fuel, because it's just the way it works. It takes a lot of fuel to get that rocket up, but then you got to, what you're burning at first is fuel that's lifting fuel when a rocket first burns. That's why they like stage rockets, plus also to get rid of the mass, a part of the containers for the fuel itself. So that's why in the past so many rockets have been staged. We're now trying to get into 2-stage orbit systems with Starship and some other vehicles. You might say the space shuttle system was kind of like that, with a hybrid system, although the SRB, solid rocket boosters, fell off soon. And then the tank fell off. But, that's almost a 2-stage orbit system. So, of course, they had this OMS burns. It gave it the final kick, OMS pods to the back of the space shuttle. Now, all this said, 45,000 miles an hour, that's a lot of velocity. It might be insurmountable for a civilization on a planet like that using rocket technology to launch a significant space endeavor. I'm not saying it's impossible, and you give them 6 billion years, maybe they could have done something from that planet if they existed. Now, let's go back more into the complexity. What I was talking about with the eyeball Earth, eyeball planet. It's where the planet always faces, one side of it always faces the sun. That side, I've talked about this in that video that I did on KO 456 -04. Actually, it's KOI, not 1. Anyway, so if you're always facing one side of your planet, the sun, that side's going to just get extremely hot. The side that never sees the sun is going to get extremely cold. And so you're going to have a very significant expansion of atmospheric gases on the hot side and a significant contraction and falling in on the cold side. So if you're on the cold side, the winds are going to come, down and around. So the winds will be blowing basically from the colder side of the planet to the hotter side. So it might be a little bit on the limb that faces the sun. You get some good cold wind, but it's going to be probably a very horrendous winds. And it may not be feasible for complex life to form on a planet like that. We don't know. Another thing, one of the exciting things about this is around a sun, virtually a sun-like star. Now let's talk about HD 20794D. That star has got a luminosity Well, it's got a mass of about 0.81 Earth mass, sun, excuse me, the mass of our sun. It's a little over 8/10 of the same mass. But the luminosity is only about 50%. That's why these planets need orbiting closer to be in the habitable zone. So our planet that we're interested in is, within the orbit virtually of Mercury, but it's in the habitable zone of this planet. But since its orbit does vary a lot, highly elliptical in the habitable zone, we don't know if that's too much of a challenge in weather systems for life. Earth's weather is dominated not by how far the Earth is from the sun, but by the tilt of the Earth, because we get more sun in the summertime than in the winter, just the way the sun is tilted. Excuse me, the Earth is tilted. So this is not scripted, guys. So now on a planet where your orbit varies that much, it's going to be the distance from the star that's going to govern your seasons. But the seasons will be fairly fast, and that may be a good thing. You don't have as much time to accumulate differences when you're only 145 days orbiting your star. Now, all that said, now atmosphere counts. If it's been stripped away because the planet has no magnetic field, forget it. If it's as thick as the Venetian atmosphere, well, you're not going to have life on the surface, maybe 50 kilometers up, like possibly on Venus. But then again, it could be that having a good magnetosphere and the extra mass of the planet has helped it to retain its atmosphere over a long time. So it may have a good atmosphere. It may have water. It may have the resources a planet needs to support life. We just don't know about the tectonic nature of the planet. So it is possible. These are some of the mitigating factors. It's the thickness of the atmosphere is one of them. But there's good prospects here, good chances. See, Venus's atmosphere is so thick because it is so close to the sun. It's had a runaway greenhouse effect. That could happen on this planet, but given how much it changes its orbit from inside to outside and the time within the fast orbit, probably not. Probably not. So seasons would be really fast on a planet like that, 145 days. What do you got? 2 seasons to get close to the star and far from the star, or coming in and going out. So you might get 4 seasons out of that. Well, they'll be quick, short seasons by our standards here on Earth. So this is definitely an interesting planet. It'd be a place to explore, a place to be interested. Yeah, good target. I got a friend, Les Johnson, who's developing these light cells or thin films that light pushes and can push at high velocities that have prospects for reaching a star. They won't go the speed of light, and you probably won't see it get there in our lifetime, but laser assisted launch of these things could get them there a lot faster. Maybe you might, in a long lifetime, see something if we can get it going fast enough. I should get Les Johnson back on here because they got a new endeavor to talk about light cells to other stars, talking about Alpha Centauri. Maybe they can get something hit at this planet and we can get better in our telescopes. Certainly, there's going to be a lot of interest in this planet since it's so close and intriguing. 4 rocky worlds that are super Earths around this planet. So, yeah, we can talk about that a little bit. And then we'll talk about the discoverer of this planet. But first, yeah, like I said, there's 4 rocky planets. I think I just killed what I was wanting to quote to you guys. Yeah. All right. So there is planet HD 20794b. It's 2.7 times Earth's mass. The orbital period is just 18 days. That's a short year. But it's within 12% of the distance, an astronomical unit, 0.12 astronomical units between that planet and its sun, HD 20794. Now, planet C, HD 20794c, is 2.4 times Earth's mass. So these are smaller planets, kind of like the one in that KOI video I did a couple of years back. But now this guy's got an orbital planet of 90 days. So you basically 3 Earth months, you got a year. Its orbital period, well, its distance from the sun, excuse me, 90 days to go around the sun, but its distance from its sun is 0.2 astronomical units. So it's 20%, only 20% of the distance from the Earth and the sun to its star. So if, like, we're out here, it's like in here, fifth the distance in. But it's thought to be potentially within inside the habitable zone. Now, the B planet B, it's going to be too hot. There's not much chance of liquid water there, but planet C, maybe, maybe. So that may be another prospect, but it is really close, like kind of like Venus. Some folks say Venus may have once had liquid water, but there's some now saying they don't think so. So maybe that's a whole nother topic to go down, a whole nother rabbit trail. So, so anyway, and of course, again, 147 days for the D planet at 0.35, a little over a third of an astronomical unit to the star. So the discovery of this star was Dr. Michael Cretigner, I don't know how he says his name, Cretignier of Oxford University. He's an assistant professor, believe it or not. He first detected this star a couple of years ago, but they were not sure that this was indeed, a planet, not a star, because the signal was weak. Now, in that video about KOI 456-04 that I covered a couple of years back, I talked about how the detection methods, and primary reason we're finding more around red dwarfs is we're looking at that star getting occulted. And then because those planets are in real close, in this case, they're in pretty close too, the star gets occulted more often, i.e., the planet makes a little bit of a shadow. That star dims, and it dims on a periodic basis according to the orbital period of the planet. But I also mentioned another technique. As the planet goes around the star, it pulls its weight, pulls on a little bit as it goes around. They orbit the center of gravity of each other, kind of, sort of. The planet does tug on the star a little bit, and it goes around the mutual center of gravity of the two. So what you would see if you're looking edge on as the thing comes around is it would be pull to you. You'd see a Doppler shift, blue, red, just a slight Doppler shift. And that, in fact, is how Dr. Cretignier, however you say his name, detected this planet. They just weren't so sure about it. So an international team just verified this recently. So they just published this fact. So he was using this instrument. How he detected this is called HARPS. Ding, 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 ding. High accuracy radial velocity planet searcher. So this instrument is actually searching based on that radial velocity. And, hopefully we'll find more planets and more sun-like systems where the planets are further away like Earth. That just takes a lot longer because, you don't get to see that occultation or that Doppler shift but once a year in case of Earth. So it takes longer to verify those planets. That's why most of the planets we're finding right now are around red dwarfs. The problem with red dwarfs is that they cast out lots of enormous flares, which would make life difficult on those planets, which may strip the atmospheres of the planets, and technological civilizations would have a hard time. You got to harden your power grid and more. They would have a tough time with the electromotive force put out by all the coronal mass ejections from a star like that, just charged particles. Now, the good thing about HD 20794 star is that it is old. Older stars are more settled, less flares going out there. So even if there's no critters, no bugs crawling around on this planet, hey, it may be a good place for a technological civilization to set up camp if you can afford to get off the surface of it. Well, there's other planets in that system, and probably moons and asteroids and other resources to be of great interest. And even if you were in orbit surveying what's below, that would be quite interesting. So there's a lot here to look out for, my friends. A lot to be excited about. So as Dr. Creetinger said, for me, it was a natural, huge joy that we can confirm the planet's existence. It was also a relief since the original signal was on the edge of the spectrograph's detection limit. So it was hard to completely convinced at that time, 2 years ago, that the signal was real or not. That's why it wasn't reported then, why it's not recently reported. He said, excitingly, its proximity to us, only 20 light years away, means that there's hope for future space missions to obtain an image of it. So, guys, but he also added, with its location, the Hubble is on relatively close proximity to Earth. The planet could play a pivotal role in future missions that will characterize the atmospheres of exoplanets and search for biosignatures indicating potential life. Then he went on to add, well, my job mainly consists of finding these unknown worlds. I'm now very enthusiastic to hear what other scientists can tell us about this newly discovered planet, particularly since it's among the closest Earth analogs we know about, and given its peculiar orbit. And given its peculiar orbit. So there you go, my friends. So that's the story of HD 20794D. Remember that name. Yeah, right. We got to give up another name, right? Just that. Leave it to astronomers and scientists to come up with some really dry names for objects, right? We need a marketeer. Anyway, my friends. So with that, I'm going to say this is Galactic Greg Allison with Galactic Gregs. If you like this content, subscribe, bang the notification bell, and click all. And look at my other videos. There'll be more to come. And with that, I'm going to say thank you for watching. Greg out.